Warm good morning to all my dear students. Welcome once again in the next topic of your Unit 1, the paper refining process for the crude oil MSCH305. This is the continuing part of the previous lecture, that is separation of the crude oil and the petroleum gas. This is the part 2 lecture. The outline of my presentation, the review of the previous lecture, the objective or the learning outcome, in situ recovery method of the oil. There are two important methods we will discuss, that is SAGD method and CSS method. Then we learn what is the offshore extraction process, the offshore development, the offshore oil production. Then we have the exercise, references, and the SELO, that is student effective learning outcome. As we all know, the petroleum products are the materials derived from the crude oil petroleum and processed out in the oil refineries. The majority of the petroleum is converted to the petroleum products, which includes the several classes of the fuels. In this lecture, students will be able to understand the oil recovery method specifically for the heavy oil in the separation of the crude oil and the natural gas. So in the previous lecture, we have learned how the crude oil associated with the natural gas is formed. That is the fossil fuel which deposit over the bed under the sea, between the rock, under the rock material over millions of the years. And it is formed along with the natural gas, which is having the major proportion of the methane and rest of the alkanes with a smaller proportion. There are different type of the natural gas we get depending on the field. We have the dry natural gas, in which we have 98% of the methane, and the 20% of the alkanes, rest of the alkanes, which are present in the wet natural gas. So there can be divided the types of the oil, the conventional oil and the unconventional oil. It depends on the geological locations and it varies from field to field. So the light oils and the medium oils we are called the conventional oils, and they can flow naturally. So they can be extracted by the simple drilling and the pumping process we have seen. But unconventional oil, in which we can have the light oil which is penetrated under the non-permeable rock, that can also be treated as the unconventional oil. So for that heavy oils whose consistency is very thick, so that unconventional oil, including LTO, light tight oil, so they are to be extracted with the advanced method. And one of the method we have seen, that is surface mining. There are two methods of the unconventional oil extraction, the surface mining and the in situ method. So we have learned how the surface mining occurs, and the trailing ponds is one of the method in which we can use in the mining. So now we move towards the in situ method. So let's start the in situ method. In situ recovery method is used when the oil is deeper from the earth's surface, is around 800 meters. Okay. So as we have learned in the surface mining, when the deposits the oil sand deposits are 70 meters from the earth's surface. We select the surface mining method, and in situ method is more deepen the oil sand deposit, that is 800 meters from the earth's surface, and that recovery method should be selected, and that is done by in situ technology. So in situ means in place. Because the bitumen is separated from the sand below ground right in the deposit itself. So the extraction process is taking place in situ below ground right at the same place where the oil sand deposition is there. That's why it is called in situ, which meaning at that place only. Understood? So this is accomplished by heating the bitumen so it becomes fluid, and when it becomes fluid it can be easily pumped to the surface. So that is the thing. There only the extraction is and recovery is taking place. So that is called the in situ, and by heating that oil sand deposits to make it a fluid, so they can easily pump to the surface. So that is the method called in situ recovery method, and that is done for the heavy oils, and which is more deepened from the earth's surface, that is 800 meters from the earth's surface. There are several ways to heat out the bitumen below ground, that is 800 meters deepen. So two commonly used methods for heating in the in situ recovery method, that is SAGD and CSS. What is SAGD? SAGD is the steam assisted gravity drainage, and CSS is cyclic steam stimulation method. Use the large volumes of the water and burn out the natural gas to create the steam, which is injected into the oil sand deposit. So the SAGD and CSS, we just see individually these two type of the method for heating the bitumen is used, and it goes for using the large volumes of the water, and it goes on burning out the natural gas which is associated with the oil, and that goes on injecting the oil sand deposit to just heat the oil and have that flow so that it can be pumped to the surface. The new research is leading to the technology that reduce or eliminate the need of water and the natural gas. So the research is going on to find out the new technology or new recovery method, so that we cannot go for using the water and the natural gas for the recovery method. So because these are the natural resources, so for avoiding these use of the natural gas and the water for the recovery, there is a research for finding out the alternative technology for such kind of the extraction. The first method, that is SAGD, that is steam assisted gravity drainage method. And in most of the in situ operations, it uses the steam assisted gravity drainage method. It mostly uses well pairs. The two wells are generated. The one is an injection well through which the steam is injected, and the another one is the production well. So drilled one above the other to recover the bitumen. So Under the two well pairs, through one the steam is injected down the 800 meters from the earth's surface, the oil sand or the bitumen, and then it requires to make the oil flow, and from the other well, when it condenses out, it is pumped out through the production well. So such kind of the well pairs is used in the SAGD method. The injection well is drilled out vertically into the oil sand deposit and then turn 90°, then go for drilling horizontally. A second well, known as the production well, is drilled deeper than the first, and it goes for paralleling out the horizontal portion of the first well. So the injection well is first vertically drilled into the deposit and then turned at the 90° angle horizontally, and the second well, the production well, it is paralleling the horizontal portion of the injection well. It is injected, but it is injected more deeper than the injection well. The steam is injected into the deposit through the upper well, that is injection well. Heated bitumen begins to move by the gravity down towards the second well. So as the second well is more deeper, so through the gravity, when it start flowing, when it become liquid, when it heated up, so through the gravity it moves down, and more deeper well is the production well. So the pumps are there in the second well which drawn out the bitumen up to the surface. The multiple wells, sometimes more than 20, it can be drilled from the single surface location and further reducing the surface disturbance. So that can be also be done by using multiple wells in the pairs, so that it reduce the disturbance on the surface and it can have the recovery of large amount of the oil. So now to have this SAGD method, so let's have one short video by the site cap.ca. So it will explain you, like the surface mining we have explained, the SAG method is also understand.
Canada's oil sands are recovered using two main methods: drilling and mining. About 80% of the resource, known as bitumen, is found between 100 and 800 meters below the Earth's surface. These reserves are too deep to be mined and are recovered in place, or in situ. One of the in situ methods is called steam-assisted gravity drainage, or SAGD. Found in formations consisting primarily of sand, the bitumen is located beneath a layer of hard rock called cap rock. In SAG-D, steam is used to warm the bitumen so it can be pumped to the surface. The operator drills a pair of wells that sit one above the other in the formation. The top well is called the injection well. The bottom well is called the production well. Steam is injected into the top well. The steam moves into the formation, warming the bitumen. With the help of gravity, the bitumen flows to the production well, along with condensation from the steam. The bitumen and condensed steam, or water, are then pumped to the surface. The bitumen and water are sent by pipeline to a central processing facility for separation. The water can then be recycled, converted to steam, and sent back to the well site to be used again in production. Bitumen is a valuable resource that can be refined into transportation fuels, such as gasoline, diesel, and jet fuel. It can also be used by petrochemical plants to create everyday products like cosmetics, textiles, plastics, and lightweight construction materials. Learn more at cap.ca.
The next method in the in situ operation is the CSS method, that is cyclic steam simulation. This method pumps the steam down the vertical well to soak or liquefy the bitumen, and it is then pumped to the surface through the same well. So the well pairs are not there in this. The one vertical well is established to provide the steam to soak or liquefy the bitumen, and with the same well it is pumped to the surface. And this technique goes on repeating many times until most of the oil is removed or recovered. Understood? So the difference between SAGD, SAGD or CSS is this, that SAGD uses the well pairs having the injection well and the production well, and in the cyclic steam stimulation, the vertical well is established, and through the same well the uh, oil is recovered, and this process is repeated uh, many times. So let's see the CSS method in a short video to understand the extraction process very properly and clearly.
Canada's oil sands are recovered using two main methods, drilling and mining. About 80% of the resource, known as bitumen, is found between 100 and 800 meters below the Earth's surface. These reserves are too deep to be mined and are recovered in place or in situ. One of the in situ methods is called cyclic steam stimulation, or CSS. Found in formations consisting primarily of sand, the bitumen is located beneath a layer of hard rock called cap rock. In CSS, steam soaks into the oil-bearing formation, warming the bitumen so it can be pumped to the surface. The operator drills a well down to the target formation and then extends the well horizontally to access more of the reservoir. CSS is a three-phase process: the injection phase, the soak phase, and the production phase. During the injection phase, steam is injected into the well. The well is then shut in at the surface while the steam in the reservoir continues to warm the bitumen. Once the soak phase is complete, production begins. The bitumen and condensed steam or water are pumped back up the same well to the surface. The process is repeated, recovering more bitumen with each cycle. Bitumen and water are sent by pipeline to a central processing facility for separation. The water can then be recycled, converted to steam, and sent back to the well site to be used again in production. Bitumen is a valuable resource that can be refined into transportation fuels such as gasoline, diesel, and jet fuel. It can also be used by petrochemical plants to create everyday products like cosmetics, textiles, plastics, and lightweight construction materials. Learn more at cap.ca.
As we understood the in situ operation of the heavy oil recovery, now if the offshore oil is there in the field, how it is extracted. The extracting the oil from the offshore is a unique process compared to the onshore oil extraction. So if it is available there near to the place, that is onshore, but the offshore required the extraction different from the onshore. Initially, the companies may begin their exploration process by reviewing the existing geological and geophysical data to learn about its potential. Before drilling, the offshore oil extraction can begin. The companies must apply the appropriate approvals from the relevant regulatory body, like if it is going to have in uh, the Canada reservoirs, the Atlantic Canada reservoir. It has to take the approvals for the offshore oil extraction method. The offshore development phase can take up 5 to 10 years depending on the size of the project, how it can be carried out, and during the development phase, the company develop a series of a plan which outline exactly how it will produce the oil and the natural gas in a particular reservoir. The environmental protection measures that will be put in place to minimize any environmental impact, the safety measures that will be used on the project, and the benefits of the project to the relevant communities and province as a whole, including the employment, revenue, and contracts. So this is a big project that should be developed in each point of view regarding the environmental protection, the safety measures, the employment, revenue, contract, communities which is to be decided. So almost this method require the development. It almost take up to 5 to 10 years to have that the offshore oil extraction method, and this is too time consuming, so it will require the proper planning and the proper work to be carried out, and the approvals which is to be taken from the regulatory bodies, and then only such kind of the method should be implemented. The production commences on the offshore oil project when all the approvals and all the environmental conditions and the measures are to be planned. Producing the oil and the natural gas offshore is a complex process due to the challenges of operating in the remote and sometimes the harsh environment. So such kind of the extraction is having a very complex procedure starting, and it is very time consuming also. The production facilities are built to withstand the offshore environment and its challenges. This is to be a very important thing to look out, including the potential for the sea ice and icebergs in some areas. What its own, and what it should be the impact after the process to be applied. So all the challenges are there for the offshore oil extraction. So it require the development, it require the approvals. So it's the big complex process to achieve such kind of the extraction method for the petroleum and the natural gas, the crude oil and the natural gas. So this is all about the separation of the crude oil and the gas. We have read the in situ operation method for the heavy oil recovery, that is SACT method, CSS method, and we have seen what challenges to be there for the offshore oil extraction method if it is carried out, and what planning should be needed. So here is the small exercise for this topic. You solve the questions: what is the in situ method here and where it is to be used. The SACT method is what, and CSS, that is cyclic steam stimulation method, you have to go and how it is carried out to better understand here, and how offshore extraction takes place, or we can say what challenges to be faced out in the offshore extraction procedure. So you go for all the questions. So these are the references. We have the petrochemicals textbook, that is the you can refer the topic from these books, and we have the reference from which I have put up the small videos of the method that can better be understood, as it is the application process which is deals with the various mining and all the extraction procedure, which can be better understand by the help of the small videos that was put by the site cap.ca. So here the reference I have taken from that. The student effective learning outcome, the applications of the concept of the topic and the adaptive thinking skills. So it is the application related topic. So it is having the concept accordingly, according to the application and development of the thinking skills for the student. So we will meet in the next lecture, and we're going to see how and which methods are used further after the extraction for the petroleum. Till then, thank you and take care.